Hi students, let's look at this question here, which is on factor theorem. Let's see how we can do this proficiently. So we are told fx is exactly divisible by this. In other words, this is a factor of fx. Okay. Now, if this is a factor of fx, which means the factor of this will be also the factor of this. Okay. So this could be factorized. Actually, you could actually see this as 2x, and this is x 3 plus 3, and this is minus 1, I believe. All right. So this is 2x. Yep, that's it. So essentially, since 2x squared plus 5x minus 3, which is 2x minus 1x plus 3, is a factor of fx. Okay, hence 2x minus 1 and x plus 3 are factors of fx. There you go. So like grandchildren or grand factors, all right? So what we do next is actually by factor theorem, we know that f half is 0 and f negative 3 will be 0 by factor theorem. Okay, so that's it. So what we're going to do is actually just substitute into this equation here. Then we could actually just solve simultaneous equation after them. Q plus q square plus 19 half minus 15 equals 0. This is it. Then the other one will be 2 negative 3 to the power 4 plus p negative 3 q plus q negative 3 square plus 19 negative 3 minus 15 equals 0. So just by keying calculator, we get these two expressions here. I'm gonna multiply by 8 because I see that there's 8 here. I'm gonna get rid of the denominator. Then in this case here, what I'll get is 8bp plus 2q equals to 43. Then I know that p is equals to, let's just solve this simultaneous equation. This is 1, this is 2. So substitute 1 into 2. What we'll get is negative 27, 43 minus 2q plus 9q equals to minus 90. Then we're just gonna could actually divide it by 9 if we want to, but it's okay. I'm just gonna distribute this in. That will be 1161 plus 27 times 2, 54q plus 9q equals to minus 90. So 161 plus 90, sorry, minus 90, 1071, then 54 plus 9, that will be 63. Q 1071 divided by 63, that will be q equals to 17. Okay, that in turn will give us p equals to 43 minus 2 times 17. That will be 43 minus 2 times 17. That will be 9. Okay, so hence q equals to 17 and p equals to 9. Anyway, let's look at show that the fx has only 2 real roots. Okay, great. I think this is pretty okay. What we can do is just do a long division, right? We just take fx, 2x to the power 4 plus p, which is 9, x cubed, q is 17x squared plus 19x minus 15. It's divisible, so we're just going to divide by 2x4. Just do a long division, okay? Plus 19x minus 15, that'll be 2x squared plus 12x minus 3. So just x squared, 2x power 4 plus 5x cubed minus 3x squared. Minus it up, this is 4x cubed plus 20x squared plus 19x plus 2x will be 4x cubed plus 10x squared minus 6x. This is 20x squared. No, this is 10x squared. 10x squared plus 25x minus 15 plus 5. This is 10x squared plus 25x minus 15. Okay, this is good, meaning fx will just be fx will just be 2x squared, one of the given factor, quadratic factor here, and x squared plus 2x plus 5 equals to 0. Okay, here. Sorry. So this we already know how to factorize this just by factorization for this first quadratic factor here. What we could do is just what we did just now was 2x and x plus 3, right? Yep. Then the other one will be here. So when fx equals to 0, we just need to examine that the two real roots come from here, and then this has no, we need to show that this has no real roots. Okay, we can just use discriminant if you need to. So for when fx equals to 0, 2x minus 1, x plus 3, x squared plus 2x plus 5 equals to 0. So discriminant b squared minus 4ac, this is actually 2 squared minus 4, 1 times 5, which is actually negative 4 minus 20 will be negative 16. Am I right? So this will be 4 minus 20. Yep. So less than 0. So hence there are no real roots for x squared plus 2x plus 5 equals 0. So thus f only has fx equals to 0 only has two real roots, that is x equals to half and x equals to negative 3. Okay, so essentially we know x equals to half is 1, x equals to negative 3, then x squared plus 2x plus 5 equals 0 is another one, which doesn't have real roots. So that's how you do this question here proficiently. If you have any questions at all, please let us know and I'll see you in the next question.